Hello, my name is Joe Vasta, and today we're going to learn a technique called the big X that's going to be used to factor a trinomial. A trinomial has three terms, and these are the ones where maybe your teacher, when you first learned this, said that this is guess and check, trial and error. There's nothing trial and error about this. We'll show you a nice, efficient way to factor that trinomial. It is broken up into 10 steps. Step 1, multiply the leading coefficient, which is 6, times the constant, which is negative 15, but I'm just going to say 15. I'm going to leave that negative out of this. So 15 times 6 is 90. So 10 steps we've already done. Step 1, we're 10% of the way there. You should feel like we've accomplished something. Step 2, you have to list the factor pairs of 90. So like what number times another number gives you 90? Well, the first one maybe you can think of is like 1 times 90. Maybe that's not the first one you thought of, but I always start with 1. How about 2 times something? 2 times 45. 3 times 30. 4 times, I don't think 4 goes into 90 nicely, so then maybe 5 times 18, 6 times 15, 7, does 7 go into 90? If you do long division, you'll see that it doesn't go into 90, and 8 does not go into 90 as well, 9 and 10. So those are all your factor pairs of 90. That is step 2. And now on to step 3. Step 3 is very simple. You circle this last sign here, okay? So this sign happens to be a negative sign, so we circle it. And that's all step 3 is. Step 4, you find the factor pair that subtracts. So that's why we circle that subtracts to give you 13. Now some of you might be saying, well, what about that negative in front of the 13? I don't care about that right now. Do we have factor pairs that subtract to give you 13? Now this one, if you subtract them or you find their difference, that's 89. And so you look at these and, well, right there, 18 minus 5 gives you 13. So we found that. That is step 4. Before we move on to step 5, let's say a few things about step 4. If I went down this list and I could not find any factor pairs that had a difference of 13, then I would say that this trinomial cannot be factored over the rational numbers. But we found one. The other thing that I want to say is if this sign was a plus, a positive sign right there, that's next to the 15, then instead of finding factor pair that subtracts to give you 13, you'd find a factor pair that would add to give you 13. So if this was a plus here, you would then you'd find ones that would add to give you 13, and I don't see any. So if there was a plus there, this would not be factorable over the rational numbers. So let's move on to step 5. Because we can factor this, I'm going to go ahead and write all factor pairs of this leading coefficient. So like kind of like what I did with the 90 over there. So I'm going to go 1 and 6, 2 and 3, and then that's pretty much all the factor pairs of 6. And then I'm going to write out or list out the factor pairs of the constant. So 1 and 15, 2, no, 3 and 5, and then 4 doesn't go into 15. So now we're going to do something with those factor pairs. Okay, step number 6 is a pretty simple step because all we're going to do is we're going to draw a big X. Okay, so that's step 6. Step 7 might be the hardest step, so let's take a look at what we're going to do. We are going to take a factor pair from the left. So you can't choose both of them. You can either choose the 1, 6 or the 2, 3. And you're going to put those numbers right there at the end of those line segments. And then you're going to pick a factor pair here, and you're going to put numbers at the edge of those line segments. Now, some of you are going, oh, here's your trial and error or guess and check. No, if we do this smartly, we don't have to guess and check. The rule is, if you go across the line, that means multiply the two numbers that are at the end of the line segment. Okay? So now what we're trying to multiply and get is we're trying to multiply to get 5 and 18. And this happens to be related to when you FOIL and you have an outside and an inside term, but I don't want to get into that. So let's take a look at 5 and 18. 5 happens to be a prime number, and so 1 goes into it and 5 goes into it, and that's it. So what you want to do is you want to probably choose that 5 and say, I want to multiply two natural numbers to get 5, and the only way we can do that is by going 1 times 5, or 5 times 1, but it's the same thing. So if we're going to go 1 times 5 on one of these line segments, let's look up here and see if there's any 5s. And there's only one place where you see a 5, and that's right there. So what I'm going to do is I'm going to circle that factor pair there, because that's what I'm going to put at the edge of those line segments on the right-hand side. And it doesn't matter which order I put them in. I'm going to go ahead and put the 3 there and the 5 there, but there's nothing wrong with putting the 3 down there and the 5 up there. Okay, so I'm working on this 5, and I want to get that 5 by multiplying 5 times a number. Well, what number would you have to multiply 5 by? Well, we already said it, 5 times 1. So we put a 1 there. And choosing that 1, we've also determined that it's this factor pair 1, 6 up there. And so you know, because that factor pair is chosen, that a 6 has to go down there. And you can double check this. Look at 6 times 3 is what? 18. 5 times 1 is 5. So this step 7 is probably the most difficult step, but if you do it a few times, you'll see that you're really not going to be guessing and checking all day. When I first saw this in school, I remember the teacher had the eraser in one hand and the chalk, yeah, that tells you how old I am, in the other hand, and I was sitting in the back of the room because my last name is Vasta, so I knew where I belonged when I went into school. They alphabetized us, and she just did a problem like this, kept erasing and writing and erasing what she wrote, and then at the end she had the thing factored and said, that's guess and check. And I sat there going, wow, I hate math. Step 7 is complete. Step number 8. So we're going to look at the original polynomial, and this is when we're going to take care of this negative. We want a negative 13. We want to get a negative 13 by adding these numbers together, or maybe we can adjust the sign on one of those or on both of them. And so if you go 18 plus 5, you're not going to get the 13. You're not going to get the negative 13. How could you get negative 13 by maybe putting some signs or a sign in front of one of these? Well, maybe if the 18 was negative and the 5 was positive. So that's what we're going to do. That happens to be step 8. Now, it's kind of a downhill ride from step 7. Because I have a plus 5, what I'm going to do is I'm going to go 1 times 5. I need a plus 5. It's already there, but I'm going to go ahead and put a plus right there. And the 6 times 3, I want a negative 18, and I'm going to put a negative in front of the 3. So there's a negative in front of the 3. So when I multiply those together, it gives me negative 18 and a positive in front of the 5. when I multiply that together, it gives me a positive 5. Now, some of you may be wondering, could I just go ahead and put the negative in front of the 6 and the positive in front of the 1? Absolutely not. Don't do that. Come on. Just do this here. It will mess up the factoring if you put the signs in front of the front term. So we want to put them here, and things should be all right. That was step 9, putting some signs there. And even if they were both going to end up being plus signs, we'd still want to put the plus signs there on the right-hand side. Okay, but one was plus, one was minus. Step 10, we are pretty much done. We circled the top one, and notice what it says there. It says 1, and then there's a big X there. 1x minus 3. Now, normally we don't say 1x minus 3. We just say x minus 3. That's one of the factors. And the bottom one says 6, and then there's a big X there, 6x plus 5. 6x plus 5, and that's the answer. And I know this took me like 11 minutes to explain, but that's because I was explaining it. It doesn't mean that it's going to take you 11 minutes to do a problem. In fact, after doing the big X many times, you may find yourself skipping some or all of the steps on certain problems. That just means you're getting good at factoring trinomials. I hope this video helps you out.